Draw a circuit diagram, digital three-phase energy meter with a load. So it's connected to a load, so you have to draw a three-phase energy meter with the load. So energy meter is a device that uses to calculate the amount of power consumed by the customer. So normally when we connect on a three-phase, the energy meter it's is sensitive to voltage, is very sensitive, so you cannot just connect it to a three-phase power line straight directly. So you have to step down by using a transformer, a potential transformer, and a CT, a current transformer. So the transformer step down the 380 volts to 110, so that the energy meter can able to be protected, to be safe from trend, because the rating of the energy meter, they differ. So this one we're going to look at, it's 110 voltage and the current is 5 amp, so it's stepping down from 20 amp. The CT, this one is for the PT, the potential transformer, and then the CT is stepping down from 20 amps to, this is the CT, to 5 amps, so that the meter cannot be damaged by the current flowing through the line. So we'll start by drawing the circuit breaker and continue on. So the circuit breaker, which is connected to the supply, so the supply the circuit breaker. So the circuit breaker, this is a device that protect the current that flowing through the circuit. So if the current is excessive of current, the circuit breaker trips to block the current from flowing in the circuit. So there are different kind of circuit breaker. So this one is used here. We have this show that it tripped over a overload of a thermal heat by excessive of heat. If there's excess of heat, this overload trips and an excessive of current. So if the current exceed the limit that the circuit breaker can handle, so it trips. So other circuit breaker can be you can reset them, you can set them according to what you want to supply on your load. So now the energy meter has a numbers in them, so we normally indicate the numbers when we connect the energy meters. For the energy meters, so we have a number like 1, 2, so it depends. This one is a digital energy meter, so there's a number until differs. This one end up at 12, other end up at 9. So we have different kind of energy meters, so you have to check the energy meter before you connect them. So what do you check? You check the ratings. So you check the rating, whether is it able to handle the current that flows. So if not, you have to go and buy the transformers, the transformer that able to step down the voltage and the current as well, so that it can able to be readable by the energy meter. Unless, if not, the energy meter can be damaged, so it have to be protected. So you connect it like this. This is a transformer, so this is a PT. So the PT step down the 380 volts to 110 volts, because the energy meter here we're using it rated at 110 volts. So you have to check your energy meters. And then this one will go to the connection on the energy meter. So this one is like a box of energy meter, and then underneath there's a where you connect the cables, the uh, the current the the current supply cable. So you have to check the size of the cable as well to connect in the right way, because some of them, if they are smaller than what the current can carry, it can not last longer because of the excessive of current that can carry by the load. So if the load draw more current, it can damage the conductor if it's small. So this one is showing it CT. So this is how we connect the CT. CT is a current transformer. It's able to step down the current from 20 to, so this side is a primary side, and this side is a secondary side. Same applies here on the CT. It's a transformer, but it's stepping downward the current, stepping down the current to a measurable value. So these are the devices that we use to, if the current is too high, or we use CT so that we can able to measure the CT current. So if you know the current, you can use the ratio, the different ratio, like from this side it's 20 amp. So every 20 amps, this one count 5 amps. So if here you find that the current consumed here is maybe 100 amp, that means you have to divide how many amp, how many 5 amps in 100 amps, so which is 20. So we multiply the 5 by 20, so it will tell you the amount of current that it consumes here. So we have to know the ratio of stepping down the current. So but the energy meter are designed to able to read the ratio. They can tell you the ratio, or you can able to calculate by yourself. So here you connect the CT on the second line. The CT helps to protect the energy meter from damage, because the load carries a lot of current. The power brings a lot of current. The supply brings a lot of current in the system, so than the energy meter can carry. So this is a start point connected to the neutral. So this should represent the load. The load can be differ, can be capacitive load, inductive load, or resistive load. So it differ according to what you are using it. This is a load, so this is a three-phase load, and then to connect the load must be balanced. So mostly you have to balance the load. So this side is the primary side, and then this is the secondary side. You can say P1, P2. Same apply here. This is the primary side, P1, P2, and then S1, S2. So this is CTs. The CTs. This is the CTs. and this one is a potential transformer, so can represent it by this, we represent it like this. But if you know how to represent it, you can use different symbol to represent your transformer. It step down the voltage from 380 to 110, and then this one step down the current from 20 amps to 5 amps, so depending on, so these one are the lines: line 1, line 2, line 3, red phase, yellow phase, and blue phase. So depending on what you are using. So this one is connected to the neutral, so the energy meter is like this. So if you want more video like this for this circuits, you can just visit here, then you'll see more circuits in the future. And thank you for watching, and see you on the next videos.